Okay, we have to look at each table individually here and decide if they're proportional or not. So remember that if a table is proportional, it has to run through 0, 0 and be linear. Okay, but that we can't see necessarily till we dig in here. If it's proportional, then it has a k value for the table, for the entire table, that every y over x value in this table is going to come out the same. So I'm going to just go 2 over 1, 6 over 3, that's equivalent to 2 over 1, 10 over 5, that's equivalent to 2 over 1, 18 over 9, that's equivalent to 2 over 1, and finally 22 over 11, which is also equivalent to 2 over 1. You got to check all the ones you're given. So all of them, when they're put in lowest terms, have the same value, 2 over 1, and it also happens to be the unit rate. So the k value is 2 to 1 or 2 when we put it in simplest form. And that means that our y value is always twice as big as our x value. It's twice the size. So there you go. That is proportional. The first one is proportional. Okay, let's take a look at this next one. We're comparing our k value this time. We're going to look to see if they all have the same k value n to m. This is our y, so to speak, and this is our x. In the table, the independent variable is first, the dependent variable is second, and we're trying to describe how this compares to this. So the first ordered pair I look at is 0, 5. Well, if my m value is 0 and it's a proportional table, my n value also has to be 0 because it has to run through the origin, and it won't be linear and run through the origin with a point of 0, 5 in it. So right away, I know it's not proportional. But I'm going to just compare just to make sure. I'm going to go 4 to 2 and see if anything else creeps in. And that's 2 over 1. 8 to 3 right there again. That doesn't work. It would need to be 8 to 4 so the relationship stays 2 to 1. So we can look at the others just because 9 to 5, 11 to 6. None of those are 2 either. So this is not proportional. It doesn't run through the origin number 1. You can eliminate it there. And it does not have a constant of proportionality value. It changes for these. All right, our next one is f and g. So I'm looking in my table and I happen to notice there's a 0 in the y. If there's a 0 in the y, just like this one, the x value has to be 0 because it has to go through that origin and be linear. And we can't have two values here that have a 0 with like a -4, 0 and a 0, 0. That would not be linear. So we're looking here just to rule out the constant of proportionality. We're going to check for it. G to f. So I'm going to go -2 over -8, which is 1/4 when we put it in the lowest terms. -8 over -16 is a half. So these do not match. And then if we keep going, -4 over -20 is a fifth. So they're not matching. And if we just do the last one, we can see that that's a third. So none of these values are the same. So this is not proportional as well. Okay, our final one. We'll pick another color here, mix it up. All right, so in this one, we're looking at an x and a y. So our k value is what we're going to look for. I don't have any zeros in my table, so I can't tell from that if it's proportional or not. I just have to use my y to x for this one. So I'm looking and I'm going y over x is a half. 2 over 4 is also a half. So far it's proportional. 3 over 6 is also a half. I'm going to check them all. Make sure that the last one, all the way to the last one works. 4 over 8 is a half. And then 5 over 10 is a half. So it's telling you that the y value is half the size of the x value. That's the relationship for this table. And because it's the same for all of them, it is proportional. So you should have clicked on this, that this one was proportional, second one was not, third one was not, and the fourth one was proportional. And that's it.